Okay, so in this video today, we're going to talk about some of the first formulae that you might want to write down on your exam paper that are not given to you in the booklet. So first of all, we have our trig squared identities. So what am I talking about here? I'm talking about our sine squared plus cos squared being equal to 1, but the other identities we can derive from that. So I first of all like to think what would happen if I divided each of these by cos. That's the one I like to do first. Well, sine over cos will give me tan squared, so plus 1. Okay, and then what's this one over here? Well, if we divided by cos, it's the one where the third letter has a c in it then. Okay, so it's sec squared. Why do I like to do this? Because it helps tell me to get the plus 1 or the minus 1 in the right place. And then how do we get the third one from that? Well, instead of dividing by cos, we can make this bit a 1. How? By dividing this top result, but by sine squared instead. Whoops. So if I divided by sine squared, I would get a 1. I would get cos over sine. That's sort of like the other way up, isn't it, to tan? So that's cot squared, okay? And then I would get, well, what's the word that you haven't seen yet? The word that you haven't seen yet in here is cosec squared. Okay, so they're not given to you in the formula booklet, those ones, but they are going to be some very, very important results. Okay, so for me, writing those ones down just very, very quickly, in particular checking I get the plus 1s in the right place is what I'm looking for. Next, I might recommend writing down the sine, cosine sort of cycle and just being careful with it to make sure that you are using it the right way around. So I think about differentiating first. So perhaps you could sort of say maybe, something like this, and just slow down and catch yourself if you are going the other way. Yeah, so if you are going the other way, making sure that you're moving that way in your cycle. Okay, it's easy to make a mistake with mixing up differentiation and integration at the best of times, but when you're sort of stressed as well, that makes it even more difficult. Okay, now there are some differentiation results that are not given to you. If I just sort of zoom ahead a little bit, this is from the formula booklet. Now, I've previously said that I think sort of knowing these results is really, really helpful, and I'm going to talk more about this in the next video. But you'll see that for trig, apart from sine and cos, it's pretty much all there. Okay? But other results that are not there, and perhaps we might be likely to forget, would be the idea of, well, when we have, first of all, say, e to kx, making sure that we do this, or more generally, if there's, a value there already, we take that into account. Okay, so that's one of our differentiation results to bear in mind. The one that people find really quite hard to remember is something like this. Okay, so I always like to think of this when you differentiate as same again. Okay, so same again being the 2x, then natural log of the number bit. Okay, so 2 to the x, and I even put the times in there just to help make it a little bit clearer what I've got in front of me, times natural log of 2. So if I said to you 3 to the x, for example, it's same again, natural log of the number bit. Now, this can come up with differentiation and integration. Okay, I'll show you one more example before we do a quick integration with it. So one thing that this does as well is it even handles situations like maybe like this, for example. So again, I remember this as same again times natural log of the number bit. Okay, so that sort of little trick I find works quite well. There's other ways of writing this. Okay, you can move this down, for example, but that is already correct as it's written. So if you're differentiating with exponentials, same again, natural log of the number bit. Now, I've seen this come up before when you've been asked to say integrate things like, 5 to the x. Okay, so we know that the answer looks something like 5 to the x, don't we, when we differentiate it? But we would get same again natural log of the number bit. So if you want to integrate something, you need to take into account that you're creating this number part. So you would have same again, and you have to sort of do something like that, yeah, to counteract the effect that when you differentiate, you will get this constant, yeah, you'll get natural log of 5. Okay, so making sure that we're comfortable with these differentiation results, okay, for these exponentials, for the sine and cosine cycle, okay, and your trig squared identities, because they love to put these ones in trig proof questions.